My name is Wale Akinfadeni, and I'm a senior generative AI data scientist here at AWS. Today, I'll be talking about automated reasoning checks in Amazon Bedrock Guardrails. I'll talk about why we need automated reasoning checks. I'll talk about what is automated reasoning, what are the differences between automated reasoning and machine learning, and then I'll also explain how automated reasoning checks in Amazon Bedrock Guardrails works. So let's get started. First, let's look at why automated reasoning checks. Today, a lot of organizations struggle with AI hallucination when moving generative AI applications from experimental to production environments. Model hallucination, where AI systems actually generate plausible but incorrect information, remains a primary concern. The 2024 Gartner CIO Generative AI Survey highlights three major risks. The first one is the reasoning errors that you actually get from hallucination. 59% of respondents actually put that as the top major risk. And then the next is misinformation from bad actors, which is 48%. And then the last one is privacy concern. So we can see that hallucination is actually at the top of this list. And so, to improve factual accuracy of large language models, AWS announced Amazon Bedrock automated reasoning checks at reInvent, which was in GitHub preview, but now it's generally available. Next is machine learning versus automated reasoning. In classical machine learning, especially when you're trying to do machine learning in sort of a supervised learning setting, you typically have large amount of data with examples of what's predicted in a supervised fashion. You have labels, and then you take the data, and then you take your algorithm, you go through the training process, you have a model that you've developed, and then at inference time, you do prediction. But we all know that the number one goal of classical machine learning is generalization. And so what you're trying to do here is that you're trying to make your model generalize to unseen data. But in most cases, it's not 100% correct. So that's the machine learning paradigm. In automated reasoning, what you're doing is that you're taking specific information, like a company policy, a business process, some workflow, a checklist, a programming code, and you're doing a translation, and this translation can be done by a human or some program, and then you have a formal language on top of it, and then you can ask questions, which is the symbolic reasoning part of it. And the idea here is that because your assumptions are correct, your results, they're accurate, they're sound, and they're transparent. And that's the difference between a probabilistic system and a deterministic system, in this case, automated reasoning. And so the next question is that how do I even apply automated reasoning to my generative AI application? And the way it works is that you have a source document, and I mentioned it could be workflows, it could be a programming code. You take that source document, you extract the concepts, the rules and the variables from it, and then you create policy, and then you can test and refine this policy. Now, this policy that you've created, they are a combination of this extracted logical representation of the source document with a formal model and that has been developed for it. And then let's say you have a generative AI application where you have your prompts with the input context, and then you have your Gen AI model application and you generate some inference in the output. So what you can do in this case is that you can use your automated reasoning policy to check the validity of the content and also provide solutions, sort of give you some explanation, right? And so automated reasoning also can actually provide some explainability on why, for example, the generated content is valid or invalid or satisfiable. And you can do many things with it. You can ask your Gen AI to take this response from AI, from automated reasoning, to use it to write the answer, or you can use it to annotate the answer, or you can then say, I want to ask clarifying questions with it. And also you can see how you can use automated reasoning as an additional check on your Gen AI application for building more reliable or a reliable application. Now let's talk about Amazon Bedrock. So Bedrock is a service that actually comes with five key components. And these key components are everything you need to build, deploy, and scale generative AI applications. And the first is you can use high-performing foundation models from leading companies, including the 1P Amazon models and the 3P partner models. You can scale cost effectively with a selection of different consumption modes, different features, and models for you to be able to balance the cost, the latency, and the quality or accuracy. Next, you can use contextual information from your company's private data sources to deliver a more relevant, accurate, and customized responses. You can implement safeguards that are customized to your application requirements and responsible AI policies. And then you can seamlessly connect with company systems, connect with APIs and data sources to be able to drive automation. And so when it comes to building generative AI applications with configurable safeguards on Bedrock, there are two types of controls that you can consider. The first one is the deterministic controls. And these are the controls that are reproducible with the same outcome that you can then audit and actually explain very easily. And so the second one in this case are probabilistic controls. And in this case, these are actually built off probabilistic safeguards. Examples of these are like prompt engineering or some checks, with Bedrock Guardrails that are designed much more for language tasks. And you can also have a component of both where you have a combination of this deterministic and probabilistic. An automated reasoning check actually falls into a component of both deterministic and probabilistic controls. Guardrails for Amazon Bedrock enables you to implement safeguards that are tailored to your application requirements and aligned with your responsible AI policies. Guardrails work with a variety of foundational models on Bedrock, and you can configure, thresholds to filter harmful content to varying degrees. You can define topics using short natural language description that actually needs to be avoided in your application. And you also can actually use automated reasoning to minimize AI hallucination, data ambiguity, and factual errors with automated reasoning check. And so safety, privacy, and security are the core of everything we do. So the next thing is, what is automated reasoning? And on the side, we have Byron, who is a distinguished scientist and VP at AWS, and define automated reasoning as the algorithmic search for new mathematical proof, right? And so what we do in automated reasoning is that we reason over evidence and we make deductions. So the automated in that case is actually automating that process. Now, to automate reasoning, you need two things. The first one is you need a logical model, right? A formal logic representation of your ground truth, right? Your ground truth in this case could be your source document or your workflow. And then you need a software to explore states, right? These are actually fast algorithms to explore a large state space. And in automated reasoning, we use solvers, or what we call SAT and SMT solver, or in some cases, we call them theorem proving. The solvers methodically search for proofs, and they can reach new, well-founded conclusions building upon existing proofs. And also, they have the ability to search an enormous state space to either find a solution to a problem or prove that no such solution exists, or decide that it cannot even decide, right? In this case, these sort of NP complete or undecidable problems. Now, in terms of logical model, creating a logical model is expensive because historically, Organizations would hire a team of logicians to actually work with subject matter experts and agree on what ground truth is, right? And so yeah, it is really expensive. And I have this image of some of the scientists that actually named, what we call AI today, in the 50s in that map. But yes, they don't work for spouse. In terms of this logical model, LLMs, they've actually changed the automated reasoning game. They changed the game because we can write logical models for pennies on the dollar. And now agreeing on truth becomes a UX problem. So when I say becomes a UX problem, it means that a subject matter expert can actually go generate scenarios, do a lot of testing, and agree on what the truth is. Next is automated reasoning checks in Amazon Bedrock Guardrails. For us, automated reasoning check has a 99% accuracy at detecting correct responses from LLMs. And we have three tenets, right? The first one is we want to be accurate. We want to be able to clearly identify factual claims that are incorrect. The second one is soundness. Soundness to us means that we won't draw false conclusions from true premises. We'd rather tell you we're not sure and you should clarify than tell you something is correct when it's not. And then the last one is transparency or explainability. So we can be transparent. We can logically and verifiably explain why we believe something is correct or not. In this case, I have a reference architecture uh, on automated reasoning checks, right? How it actually works with Bedrock guardrails. The first thing is you have a source document. You prepare this document. You have you include the intent description, and then you upload it. Automated, rules and variables are created, and then you can go back as a subject matter expert to generate scenarios from these rules and variables. And also you can refine the policy based on that. You can have a lot of different versions. You can even import or export additional document. And when you have a really you have a policy that you like and you think works, from the testing and the refinement process that you've done, you can then take that and you can associate the AR policy and the version to Amazon Bedrock Guardrails, and then you can use that for your generative AI application as a configurable safeguard. When does it work best? Actually, automated reasoning works well to validate factual claims and procedures, right? Things that boils down to a yes or no, or always never, that boils down to yes or no, always never, right? So things like HR policies, laws and regulations, operational workflows that are deterministic in nature. We've seen that it's not suited for um, really things that are probabilistic, like marketing messaging best practices, or what are the chances of, or even things like qualitative description. We actually don't think automated reasoning is suited for those. Also, we've worked with a lot of customers um, during the preview phase and the pilot phase, and there are a lot of use cases. And in this slide, I have some potential use cases, right? In healthcare, for example, for validating clinical documentation compliance. In financial services, where you can use it to verify transaction compliance, or you can actually validate credit decisions in insurance, for claims decisions, or for policy documentation. In manufacturing, we've also seen actually work on use cases in travel and hospitality, where you can use it to validate things like booking policies, or you can use it to verify pricing calculation. So in summary, automated reasoning checks in Amazon Bedrock Guardrails can be used as a configurable safeguard as part of guardrails to minimize hallucination and to make sure that you have all your factual claims are actually accurate. Dan, thank you so much. And yeah,